Hello and welcome to Algebraic Method to solve unstable games of size 2 by 2. Up till this point we have seen what a game is, how to solve stable games, and if a game is not stable, if a game is unstable, then how can we solve it using orderment method. Now to solve an unstable game of size 2 by 2, we have two methods. Either we can solve it using orderment method or we can solve it using algebraic method. So we'll summarize what we have learnt up till this point and then we'll proceed with our today's discussion. First step is stability. If a game is stable, then we get a solution. We get a saddle point, we get a value of the, we get strategies of the player, strategies for the players, and we get value of the game. Check for stability. If stable, then find solution. Saddle point, strategy, and value. If a game is stable, this is what we have learned up till this point. If a game is unstable, then in unstable we are dividing them into 2 by 2. Right now we are studying only 2 by 2. Right now we are confining our discussion to 2 by 2 games. If we have an unstable game of 2 by 2, you can either solve it using orderment method or algebraic method, as we are going to see today. Today we'll talk about algebraic method. To solve unstable game of size 2 by 2. This is what we'll be discussing today. So let us start with our discussion and we'll see how algebraic method advances. Now what is algebraic method? First let us have a look at algebraic method and then we'll take up questions, and we'll take a stable question, we'll take an unstable question, we'll solve it that unstable using orderment method, we'll solve that unstable using algebraic method. So first let us understand what this algebraic method is. Suppose this is our general purpose game. General game is, we have a row player who has strategies A1 and A2. We have a column player who has strategies B1 and B2. A11, A12. First row, first column, first row, second column. Then we have A21, A22. Second row, second column. Second row, first column, second row, second column. First row, first column, second column, second row, first column, second column. Now, if A selects strategy A1 with the probability of P, then what is the probability of selecting second strategy? It is 1 minus P. If B selects first strategy with the probability of Q, what is this probability of selecting the second strategy? It is 1 minus Q. Is that fine? If I take this with a strategy of 0.4, then strategy of selecting this would be 0.6. If you remember our previous question, I believe there was 4 by 5 and 1 by 5. And then here we had, I believe, 3 by 5 and 2 by 5. So what is the probability of selecting first strategy? It is 0.8. If probability of selecting first strategy is P, then second strategy becomes 1 minus P. If first strategy is 0.8, second becomes 1 minus 0.8, that is 0.2. This is what we are trying to say over here. Now, because we are preparing a general model, I am not sure what will the strategies be, what will the probabilities be, what will the payoffs be. So I am calling them A11, A12, A21, A22. Strategies are probability of selecting first strategy P, second being 1 minus P. Probability of selecting first strategy for column player Q, for second strategy is 1 minus Q. If this was 0.6, this was 0.4. So we have seen in past that this is how odds, this is how strategies, this is how ratios go. In stable games, the strategies are probability of 1 and all other being probability of 0. In mixed, in unstable games, it could be 0.8, 0.2, 0.6, 0.6. We saw 50-50. So strategies could be anything. Idea is, if there is certain chance of picking first strategy, the remaining is chance of picking second strategy, 1 minus P. This is generalized assumption on which we are proceeding. Now, we know that value of game is product of picking any strategy multiplied by expected return. This is not necessarily coming only out of Aditya method that we saw previously. Yes, we talked over there that if we understand this thing, it is easier to operate algebraic method. But what is expected return? If you have studied probability, you would have studied that gain in probability. If there is 60% chance and 40% chance, 60, let us say 0.6n. If there is a 60% chance of winning 100 rupees and there is a 40% chance of losing 100 rupees. If I place a bet, there is 60% chance that I will win 100 rupees. There is a 40% chance that I will lose 100 rupees. What is my return? What is my payoff? How do we calculate the expected value? If I play this game, what is the expected value? 60% chance of winning 100. 0.6 into return. Probability into return. Also 0.4, there is a chance of minus 100, making it 60 for this, and this becomes minus 40, making it 20. So if I play this game, what is my return? If I play this game, what is value of game for me? There is a 60% chance that I'll win 100 rupees, 40% chance that I'll lose 100 rupees. So if I play this game n number of times, ultimately I'll have on an average a gain of 20 rupees. This is what we mean by expected return. So probability multiplied by return. Probability multiplied by return. This is what we did in Aditya method. Now, the idea over here is that we saw last time that from whatever perspective we see, whatever combination we take, value of game remains same. Obviously, my return should remain same. If my return is again changing, if my return is 100, if my return is 80, obviously I'll reject the 80 return, I'll go with 100 return. I'm stuck in a situation where both are giving me 60-60. So I could go with this, I could go with other option. Idea is this multiplied by this or this multiplied by this, both gives me same return. As we saw in Aditya method, we checked there practically. We found out this combination, this combination, this combination, this combination, all four combinations were yielding me same value. That property we saw over here also, and that property will apply here also again. What is that property? That probability multiplied by respective returns gives me value. Then again probability multiplied by respective return gives me value. And these both values should be same. This is what I'll be using. So let me call it V1 for the time being. P into P multiplied by A12 plus 1 minus P multiplied to, this is my value coming from this combination. Is that fine? Then value coming from my second combination will be P multiplied by A11, 1 minus P multiplied by A21. Probabilities multiplied by returns. This is what we saw in previous case also. This is what we checked right now also, that probability is multiplied by payoffs. What are payoffs? Returns. There is a P probability that I'll get A12 return. There is a 1 minus P probability that I'll get A22 return. So my complete return would be sum product. Product on sum. But I very well know that V1 should be equal to V2. These cannot be different. If these are different, I'll reject the inferior one. If this is 100, this is 80, I'll reject the 81. This will be the value of game. But in unstable games, we have checked, as in previous case, that value should be same everywhere. So I can say that V1 will be equal to V2 implies this expression will be equal to this expression. Let me put it down. A12 plus 1 minus P A22 is equal to P A11 plus 1 minus P A21. So I have an equation. Because V1 is equal to V2, I very well know, I equate this equation to second equation. PA2, 1 minus PA22, PA1. Now, if we try to solve this algebraically for value of P, I need to understand what is my strategy. If I get my strategy for A1, I'll get my strategy for A2 also. Because this has a relation of P and 1 minus P. If I get my relationship for Q, a value for Q, I'll get the other value also. For now, I am not talking of Q. For now, I am talking only of P. So, this is my algebraic expression. Can I solve it for P? Let me try and solve it for P. What do we get? If I bring everything over here, we'll get, we'll not bring everything over here, we'll expand them first. So, I get PA12, this will give you plus A22 minus PA22. This will give you PA11 plus A21 minus PA21. Let me check if this is correct, minus PA22. Then we had a PA11, A21 minus P. We have just expanded this 1 minus P. Now we can arrange them, bringing all P's on one side and remaining stuff on other side. We get P A12 minus P A22. These two are P terms. This is a non-P term. I'll send it over there. This is a P term. Let me bring it over here. If this is positive, it will become negative, minus P A11. This coming here would make it a plus P A22, and then remaining non-P terms are A21, and this also goes over there, making it minus A22. So I have PA12 and so on. Now if I could try and pick up some commons, we have an A21, PA21, where is PA21? This is here, this is here. Okay, this was wrong, I told you, na? PA11, A21, this is PA21. Coming here, it will become PA21. So I have 1, 2, 2, 2, everything is over here. Now, we can take something common over here. If I try to take common, what does it become? It becomes P A12 minus, I am taking P common from all these. It becomes A12 minus A22 minus A11 plus A21 is equal to A21 minus A22. And for these, it will be better if we form some groups. Those groups would be like A21 minus A22 plus A12 minus A11. It is same, I am not touching it, I am just making some logical groups because I have an A21, A22 over there, making it A21 minus A22. So what will be the value of P? Value of P will be A21 minus A22. upon in bracket A21 minus A22, then we have A12 minus A11. This is value of P. So in algebraic method, you need not find out odds. You can directly use this formula to find out value of P. And what is 1 minus P? If I try to find out 1 minus P, 1 minus P is equal to 1 minus this complete thing. What is this? A21 minus A22 upon A21 minus A22 plus A11 minus A12 minus A11. 1 minus P would be 1 minus, this is the value of P. If I try to solve it, LCM becomes this, A21 minus A22 plus A12 minus A11, 1, making it A21 minus A22 plus A12 minus A11 minus A12 minus A22. If you look carefully, A12 minus A22, A12 minus, sorry, this was A21. A21 minus A22, A21 minus A22. This is positive, this is carrying a negative sign. So you get A12 minus A11 upon A21 minus A22 plus A12 minus A11. This is value of P, this is value of 1 minus P. This is the algebraic method. And similarly, can we try to find out value of Q also? Let us see. If I write down this kind of equation, Q into A21, Q into A21 plus 1 minus Q into A22. Q into A21 plus 1 minus Q into A22. This has to be equal to this combination also, which is Q into A11 plus 1 minus Q A12. Same as this. Exactly same as this. This combination plus this or this combination plus this. Both have to be same. Now again, if I expand this, it will become Q A21 plus A22 minus Q A22 is equal to Q A11 plus A12 minus Q A12. If we bring Q's on one side, we'll get Q A21 minus Q A22 minus Q A11, this coming here, plus Q A12. There I am left with A12 minus A22. If you take Q as common and try to form this kind of groups, सबसे पहले we'll have A12 minus A22. And second one would be A21 minus A11 is equal to A12 minus A22, thereby giving me Q as A12 minus A22 upon plus A21 minus A11. This is Q. 1 minus Q would be, you can see P was A21 minus 22. I have 1 2 minus 2 2. Remaining was, everything was same. A12 minus A22, A21 minus 22. So exact same thing. 1 2 minus 2 2, 1 2 minus 2 2. 2 1 minus 2 2, 2 1 minus 2 2. That was the remaining combination. 2 1 2 2, 1 2 1 1. So this is a bit complex thing, and if I go by symmetry, P was this, 1 minus P was this, 1 minus P was this thing upon complete, 1 2 upon complete. So if I go by symmetry, these are common. This one would be A21 minus A11 upon A12 minus A22 plus A21 minus A11. Now this is our algebraic method. Here is value of Q and here is value of 1 minus Q. So you can find out P using this, 1 minus P using this, Q using these, and 1 minus Q. This is our algebraic method. Now, this was derivation of these formulae. If you can remember these formulae, well, very good. If you cannot remember these formulae, you can always move to ornament method. We'll take a question which will solve using ornament method also and this method also. Fine. So that we can compare how do these methods progress. Let us take a question. Let us take an unstable question. Let this be B1 and B2, A1 and A2. We have our row player and column player. Let the values be 4, 8, 10, 12. Maximum, 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 minimum. Minimum, minimum, maximum. This 10 is pointing here, this 8 is pointing here. So this is an unstable question. If this is an unstable question, can I solve it using ornament method? The ornament method would give me 4, 10, 12 and 8. Difference of these two. Difference of these two would be 6, difference of these two would be 4, difference of these two would be 8, difference of these two is 2. 8 plus 2 is 10, 6 plus 4 is 10. The sums should be same. So this is an unstable and sums are same. 10. 2 plus 8 is 10. So what is strategy for A? Strategy for A is 4 by 10 and 6 by 10. Strategy for B is 2 by 10 and 8 by 10. And value of game is 4 by 10 into 10 plus 6 by 10 into 8. You can pick the odds, you can pick the probabilities and multiply them to returns respectively. If you are taking 10, then you have to take 8. You could have gone with this combination 4 into 4 plus 12 multiplied by 6. 4 multiplied by 4 was 16 and this was 72, 84. Right now what we are getting? We are getting 40 plus 48 upon 10. 88 upon 10. What was that? 4 multiplied by 4 is 16, 12, 6 are 72. Sorry, 16 plus 72 is 88. So if I take this, it is 88. If I take this, 16 plus 72 is. So this is my solution. What is my solution? Strategies for A and B and value of game. Now if I try to solve this question using algebraic method, let me see. If I try to solve this algebraically, what will be the value of P? Value of P would be A21 minus A12, A21 minus A22. A21. What is A21? This is A21 minus A22. 12 minus 8, giving me 4. A21 minus A22. 12 minus 8 giving me 4 upon 21 minus 22, that is this, plus 12 minus 11, 12 minus 11, 12 minus 11, that is 10 minus 4, which is 6, giving me 4 by 10. P is 4 by 10. So 1 minus P would be 1 minus P. Either you can find out directly from 4 by 10 or we will try to find out algebraically. 1 2 minus 1 1. 1 2 minus 1 1. 10 minus 4. Then we have 2 1 minus 2 2. 2 1 minus 2 2. 12 minus 8 is 4. And then finally we have 1 2 minus 1 1. 1 2 minus 1 1, that is 10 minus 4 is 6. So we have P and 1 minus P. 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 Ornament method was giving me 4 by 10, 6 by 10. Even algebraic is giving me 4 by 10 and 6 by 10. If you try to find out Q, 1 2 minus 2 2. 1 2 minus 2 2. 10 minus 8. 2. 1 2 minus 2 2. 10 minus 8 is 2. Then there is a 2 1 minus 1 1. 2 1 minus 1 1. 12 minus 4. 12 minus 4 is 8, giving me 2 by 10. 1 minus Q, if we find out from here, it will be 8 by 10. 2 1 minus 1 1. 2 1 minus 1 1. 12 minus 4, 8. Upon 2 1 minus 1 2 minus 2 2. 1 2 minus 2 2. 10 minus 8 is, okay, I'll put it over here. And 2 1 minus 1 1. 2 1 minus 1 1. 12 minus 4 is 8. By 10. So we see that we are getting same odds, same probabilities, but through different method. Now the choice rests with you. You can either use the ornament method, this much, or you could use the algebraic method. Algebraic method makes use of these formulae. If you can remember these formulae, you can straight away find out your odds. And once we have these odds, we can always find out value of game. Fine. So this was a slight comparison between ornament method and algebraic method. This is derivation of algebraic method, probabilities of P, 1 minus P, Q, 1 minus Q. And this is a little bit of comparison between our two methods, algebraic method and ornament method. So this was it for our today's discussion on algebraic method. Now we have advanced from stable games to unstable games. Unstable games, we have talked about 2 by 2 games using two different methods. Now you can pick your best method. I always suggest ornament method is best because it is easy, it is straightforward. It gives us a very quick check if we are on right path or not. The sums will always tell me that I am on right track. 8 plus 4 is 12. This was something wrong. Okay, this was, we were checking about stability. 4 plus 6 is 10, 8 plus 2 is 10. So ornament method is always suggested, but if your question suggests so, if your syllabus suggests so, you can go with algebraic method. This is derivation of how we get to this value, how we get to this formula. It is a symmetric formula. If you can remember it for P, you can derive it for 1 by minus P, and same symmetry follows in Q and 1 minus Q also. So this was it for our today's lecture on solving an unstable game of size 2 by 2 using algebraic method, and a little bit of comparison between ornament method and algebraic method. Until we meet next time, do take care. Thanks for watching. Bye-bye.